we think division, perhaps. An example, factors of 10. Some people think of all the numbers that can evenly divide into 10. So I know 1 can go in, 2, 5, and 10. That was the example Darcy created. All the numbers that divide evenly into 10 are factors of 10. When I say evenly, I mean no remainder. We don't get decimals or anything. We only deal with integers here. That's positive or negative whole numbers. So the factors of 10, 1, 2, 5, 10. So they all evenly in. So no remainder. Now I've done a bracket inside a bracket there, like order of operations. No remainder. So let's do another example of factors. Let's do factors of 12. Anyone think they can list all factors of 12? Liam? 6. 2. 4. 1. What's he missing? 12. One more he's missing, I think. 3. So one way of doing the factors of a number is to do factor pairs. Someone mentioned, I can't remember who. Factor pairs are the two numbers that together multiply to give. So you think multiply a little bit. 1 times 12 is 12. You think of all the things that multiply to give the number. 2 times 6 also gives 12. 3 times 4 gives 12. You think to your times tables. Now in reverse, because multiplication is the exact opposite of division, these would divide then into 12. 1, 12, 2, 6, 3, 4. So they're the factor pairs. Usually it's a good idea to write these in order. 1, 2, 3, 4, 6, 12. If you're not sure what factors are, you definitely should be writing a note on this. Maybe give an example or both examples and what factor pairs are. If that's new to you, also write a note on this. Definitely don't be playing with your water bottle. Have your book open and have a pen in your hand. Yes, sir. Factor families. Tell me about factor families. A bunch of numbers. We'll come back to that. Okay. That's factors. There's some special numbers that only have 2 factors. What are they called? Casper. 6 has got 1, 2, 3, and 6. That's 4 factors. Kiki? 2? 2. What's special about that? Only has 2 factors. What's that type of number called? It's a prime number, yes. So a number with 2 factors is prime. Prime numbers. Now I'm going to rub out multiples for a minute and talk about primes. Once again, if you're not sure, a note is a good idea. Prime numbers. Anyone list the first 5 prime numbers in order? In order.
2.
Akira's going to, yeah.
1, 2, 5.
Oh, you made a mistake there.
1, 2, 6.
Well, you said the classic. 1. Is 1 a prime number?
No.
Why not?
Because it's a single thing. 0.5.
2 factors. 2 factors. It's itself and 1. Okay. 2, 3, 5, 7, 11, and so on. 13, yeah, is the next one, and so on. Okay, so they're prime numbers. They only have 2 factors. 1 isn't prime because it only has 1 factor, 1. It's repeated, 1 times 1, but it is only 1 factor. That's one explanation why it's not prime number. Yes? 9, good question. 9 has 1, 3, and 9 as factors. That does not pass the test. That has 3 factors, yes. 7, 1 times 7. Anything else multiplied to give 7?
Nope.
No.
I mean, there could be. 1 times 11.
Just shouting out things. Okay, so prime has an opposite set of numbers. What's the opposite set where you have more than 2 factors? Well, what's that called? There's a set of numbers that have more than 2 factors, like 9 and 10 and 16. They're called what? Composite. So primes have 2 factors. Composites have more than 2 factors. What's the first composite number if we started listing the composite numbers? Annie? 4 would be the first one we would list, yeah. Next one? 6. 8. Then?
10.
No, 9. So if you said 10, you were wrong. Because, of course, 9 has 3 factors. That's more than 2. And so on, and so on, and so on. So almost all even numbers, 4, 6, 8, 10, 12, etc., have more than 2 factors, because 2 divides into them. But 2, of course, only has 2 factors, 1 times 2. Make sure you've taken any notes if you're not sure of any of these. So I'm going to move on to multiples. So that's factors. Factors we think divide. 10 can be divided by 1, 2, 5, and 10. They come in pairs, factor pairs. So you can think about multiplication, but mostly we think about division. Multiples must be about multiplying. They're about the times tables. Multiples think multiply. The multiples, I'll start with an example. Multiples of 6. The first one is 6. Does anyone think they can list all of them? Who can list all of them? Darcy, you can list all of them. Go. 6, 12, 18. Okay. Yeah. 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 I thought you listed them all. All of them. Keep going. 96. Go. Okay. Darcy is going to list them all in his head forever. He's just going to answer that question for the rest of his life because, of course, there are an infinite number. So we normally say list the first 5 multiples of something. So that's an example. Lois?
So the prime number is 2 factors and the composite number is more than 2 factors. What is 1?
It's its own special number. Its own special one. It is neither a prime nor a composite number. It's nice. It's actually a square number. Because 1 squared, 1 times 1 is 1 squared. Yes? We're talking about natural counting numbers here. Okay, 2 good questions there. Flynn, you with me? Finn, you know all this? You know all this already? You're aware of all this already? Yeah? No need to take a note for you? No need to have your book open, pen in your hand? Good on you. Liam, same? Okay, great. So good question. Negative numbers, are we dealing with negative numbers here? No, we're only dealing with natural and counting numbers, whole numbers only. So a question might look like list, because we can't list all multiples. List the first, list the first 5 multiples of 12. Who thinks they can list the first 5 multiples of 12? Kiki, go.
12, 24, 36, 48, and 60.
Very good. So the first 5 answers to the times tables. How would you do it? 1 times 12, 2 times 12, 3 times 12, 4 times 12, 5 times 12. So you're just doing the times tables. When you're doing multiples, think multiply, they're the answers to that particular number's times table, starting with the first one. Okay. I'm presuming some good notes there. Yes?
So basically, the factors show you the answer of the function and the multiples show you double.
Kind, yeah. Multiples will always be the same number or more. Factors will always be the same number or less. Factors are smaller. So you want to make a note of that. Multiples are usually more or the same, are always more or the same, and factors are always less or the same, you can put in. So if you think of the number 12, 12 itself is a factor and a multiple of 12. But that's the only one they'll share in common. After that, all multiples will be bigger and all factors will be smaller. Okay. We will finish today with a Kahoot, so get your devices out. I do hope you've taken some notes on that.